Hello, I'm Chris, and I'm your host for the Android Office Hours. Welcome to the second edition of this series. We have had a couple of technical snafus, which is why we are a little bit behind. From my understanding, we're also not quite live on LinkedIn just yet, so the folks on LinkedIn, please bear with us for a second while we solve that technical issue, and we'll be streaming on LinkedIn as well. Um, but for now, welcome to the second edition of the Android Show. Like I said, my name is Chris, your host. I'll be joined today by Harun, a Google developer expert from Kenya, and he will walk us through um, offline architecture on Android. We have a packed agenda for you today. Unfortunately, I'm a little bit under the weather, so um, I'll be a little bit off screen most of the time, but it should still be a good show. Without further ado, let's get started. Um, I'll give you a couple of ecosystem updates. Um, the big one, as you may know, or may not, uh, if you live under a rock, was the Android show just yesterday, the, the day before, sorry, on May 12th, where we announced a whole host of new goodies for Android. Everything from Gemini Intelligence to the big revamp of Android Auto, for developers, goodies like app functions, to and so on. Please head over to the Android Show site for uh, um, more details about all of this. Lot of news and goodies. As far as events are concerned, we also have the big events of the year, IO, next week. We hope that you tune in for all the announcements and all the goodies that we have prepared for y'all. Next, here today will be Harun, um, like I said, is a Google developer expert, longtime Android developer out of Kenya. He will talk about how you can design your app to be offline first. We know that building in regions like sub-Saharan Africa, the Middle East, or anywhere really in the world where connections can be tricky to deal with, or bandwidth can be tricky to deal with. Having the correct architecture, having the a hardened architecture to be able to handle offline interactions, and have your users still have a great experience is very important. So, without further ado, I'll give it to Harun. Welcome to the show.
Thank you so much, Chris, for having me here. And hi, everyone. I'm Harun Wangereka, a Google developer expert for Android, and also a senior mobile engineer at SmileID. So today, I think I want to walk us through a very interesting topic, that is offline first architecture. This is a topic I love so much, and would love to share some of my experiences across different companies and also some of the experiences that I've had so far. So we are going to speak about best practices for room, local caching, and also sync patterns, so that these are the patterns that will hold up where network doesn't. But first of all, let's look at some numbers here. Like a typical sub-Saharan Africa Android user, you'll find that we have 37% of Africans use mobile internet. These numbers, I got them from the GSMA Mobile Economic Report. And then the other thing is you'll find most of the people live in intermittent and then low bandwidth connectivity. And most of these devices that people use, you'll find they have 1 to 2 GB of RAM, and then less than 8 GB of storage. And also we have 2 to 3G network connectivity in most of the last mile villages. What does this mean for mostly engineers when you're trying to design your apps? So designing for apps that work for the sub-Saharan region means that you're designing for low memory, limited storage, low bandwidth, and also a network that drops in and out in an hour. So I think as you're thinking of how to design your apps, these are some of the restrictions that you have to have in mind before you actually think about the architecture. And because we're also thinking about the MENA region, uh, it has like a slight shift where we have like network coverage about 50% of the users. But the only thing is you find that we have a slow adoption, and the other restriction is we have tighter battery policies. What does the devices look like? So I think we have 4G or 5G of network connectivity. And then we have like DOS mode plus. This is a coin word that I used. So DOS mode is a feature in Android where you have, it can put like your phone in a deep sleep when I think you're out of resources and all that. So you have most of the OEM, I think, built on top of this DOS mode to actually restrict how you use the battery and how apps do things in the background. And then the other thing that you should consider is also the right to left. So what does this translate to the engineers as well? So when you're designing for the MENA region, you have like tighter battery limits, and you also have roaming for users. I think if you're going from country to country, you'll find that network drops in terms of quality and all that. And then you also have to put the RTL policies in mind, where you're not just translating, but you have to have like the left to right layouts in mind. In this session, I think I'm going to use two real-world examples. They use the same patterns, but they have different problem domains, and they have also been proven in production. So the number one example is the Now in Android app. So you can find it on GitHub. That is the link when you go to the Android GitHub repositories, and then you'll find the Now in Android app. It's a app by Google that shows you how to some of the modern Android architecture practices, local room DB, repository pattern, WorkManager, and all that. There's also a common example that is very common in sub-Saharan Africa, where you have a field agent app. Most startups normally use this kind of situation where you have an agent who normally goes to the field, and the field can be, let's say, you're going deep kilometers into the last mile villages, and you'll have hours of offline stretch, and then you have to save all these things locally first, and then you have to sync them later when the agent has internet connectivity. And then most of the common scenario is in these villages, you'll find that the network is very patchy, and then mostly it will be 2G or 3G, and it's not like the common internet that you'll find in mostly major towns. And yeah, so I'll start with the canonical guide. So if you go to developers.android.com, I think there is 4 decisions, mostly for offline fast architecture, that you have to first think about before you actually even write the architecture. So the number one thing you have to ask yourself is how do I read? So this normally tells you how to read data. So you can have one option as cache only, where you only read the local copy and then you never hit the network. The other option is you have a cache plus a fallback. So here you return from cache, and then when the cache doesn't have any data, you have a fallback from the network. The other option is you have a cache plus refresh. So you can return the cache, and then after the cache, you can refresh in the background. The other decision that you also have to make is how do you write? Number one, we have like the reject offline. So if you don't have network, you just say you have an error. You also have like a queue for later where you store the write and then send it when the network is back. The other option is local fast. So you fetch it and then write to the local database and then upload in the background. The other option thing that you also have to think about is how do you sync? And there's two ways here you can sync your app, where you have like an app-driven approach, where when a user opens your app, you can have like a pull to refresh option, or when a user completes an action inside your app, you trigger like a sync. And then you can also have like a network-driven kind of a sync, where you use network managers to do background jobs. And then you can also do things like when you receive like a notification from Firebase, you start like a background job and all that. And then the last one is how do you handle conflicts, and who wins when there is a conflict. So you have like the first option, where is the last right wins, where if you have new at timestamps, that is the case where you win. And then you have like a server authoritative case, where you only treat everything that comes from the server as the source of truth. And then the last option is you have like a per field merge, where you compare each and every field and then decide per field, either you have to merge or you have to treat the local as the source of truth. So the only thing to highlight is here, most of the bugs that you face on offline fast apps is they're not bugs, but they are bugs that are in code. So you have to think about all these four options and then document them clearly on your application, so that everyone kind of knows this is how we treat reads, this is how we treat writes, and then this is how the app is syncing. And then lastly, this is how we treat conflicts in case there is conflicts. And a quick recap on the concepts that we are designing around. As I mentioned, is we have like low RAM, that is 1 to 2 GB. So anything that is over allocated, the app will be killed. Secondly, we have like small screen. So you can't really render large things or complex graphs, animations, and all that. Because when you do that, I think you'll find that your app is very sluggish or your app is very slow. The other thing you have to think about is also low storage. So your app most of these times is competing with other applications to compete for storage. So when you're designing your application, you also have to think about that. And then you also have to think about the network, as I mentioned. Sometimes it can be patchy. And then when you're uploading large sizes of data, you have to also consider like the network in that aspect. And to explain, most Android apps treat the network. It's mostly not a bug, but you'll find most tutorials, this is how they teach you to approach like the network. So you have a network call that you can do in retrofit or ktor. You have like a spinner that shows you're fetching something. And then in case we have an error, you'll maybe show a toast or maybe an error message on the screen. And then cache will be added later when the responses is slow. And then probably there'll be like a sync to refresh if you need to fetch new items. And then lastly, if you need to write to the API, it will go straight to the API. So the problem with this, I think it works until it doesn't. And I think most of the situations is where you are told like the app is not working and it's already probably deployed on Play Store. So when the network is fast, reliable, and you have like a fast internet, I think this will always work. But if you go to areas where you have like 2G internet and then a very slow phone with like maybe 2 GB RAM and all, you'll find that probably this might not work. And that's where the mental shifts comes in. So you have to treat like offline, not an error, but you can make it a default state. So we have like a first scenario on the left, where you have like an online first scenario where the network is the source of truth. You have the cache, which is used when the network is slow. And then errors can stop the user. And then the sync has to be manual. And then writes go straight to the API. And then the shift is you're going to do like an offline fast kind of an architecture. So what does this look like? So you have like the local DB as the source of truth. Network is an enrichment, not a dependency. This means that your app can work in areas where you don't have a network. And then errors are first class and recoverable. So you treat errors as a first class citizen, and then you provide ways of recovering the errors. And then you have like a sync in the background that runs, and then it can be triggered on its own, so that the user doesn't have to manually do the sync for it to happen. And then when you're trying to do the writes, they first go to local, and then you can upload them later. So I'm going to walk you through how we can actually design this for offline fast architecture. and discuss some of the lessons that I've also learned over the years. So number one, we have what we call the repository pattern. I think this is where you have like a repository, which is like a one big brain, and then you have many sources of data, and then everyone inside your application talks to the repository. So in that diagram, you can be able to see we have like one repository, and then we have a local data source and then a remote data source. So what the repository does is it acts like the single source of truth, or determines which is the source of truth for your data. So for local data source, you have examples like Room, DataStore, files, and remote data source. You can have like a REST API and then gRPC or WebSockets. So what the repository does, it will always know this is the source of truth, and then when I get data from, let's say, local data source, this is what I'm supposed to do. And then for your UIs, you're supposed to observe from a view model, and then your UI will never know where this data is coming from. That is how the repository helps. So you have like a repository, and then the UI normally calls the repository and gets like a new set of data. And then for reads, so let us see how the local reads normally work with this one example. So you'll expose a flow from Room. So flow is a reactive stream from Kotlin, which allows you to observe data in real time from like your local database. So you can read a flow list, which is, for example, this example of the data access object on the right. You can see we have like an observable, which gets a list of users. And then the return type is a flow. And then this is a list of users. And then on your UI, you will collect it with the collect as state with lifecycle. So this is a helper from Jetpack Compose that normally observes data, and then when the screen is no longer visible, it will actually stop the observation so that you can save up on resources and all. And then when you have like a sync, it will first write to Room database, and then the flow will re-emit again, and then your UI will get the updates from flow. And then even if you launch your app from like an offline situation, you'll still get the latest set of data because you've already handled that case. So I think on the right, that is the data access object, and then we have like a repository which just calls the data access object and then gets the list of all the users. And then going back to the sync part, so we can have two flavors, which I'll discuss on this session. And then you have to pick deliberately depending on what your app needs. So the first flavor is you have a sync where it's app driven. When the user opens the app, they navigate probably to a screen or they can pull to refresh. So that is when you do like a refresh on your repository. So that is one version. And then we have the network driven kind of sync where you have periodic background work every few minutes or every few hours, depending on how you want to configure that. And also when your constraints are met, you start the background job. So, and the implementation bit is you have WorkManager, which is like a class that really helps you in doing all these background jobs. And then inside your WorkManager, you can configure it with periodic work requests, and then you can add constraints like network type connected. So this will only ensure that your background job will only run when the user has internet. And you can go further to configure it to your liking. I think we'll see some examples later on. So you'll find that in most production apps, you might need both approaches so that you can have fresh copy of data every time. Um, so when you're talking about sync, we have a thing called bandwidth, and I'll have this concept called delta sync to only say fetch only what changed. So because, for example, if you did a fetch in the morning, you don't need to fetch again the whole list of users, uh, let's say at noon. So you have to configure it in a way that you only fetch the list of things that have changed since the last time you sync. So this is one approach where you have one query parameter when you are maybe one query parameter. So you have, let's say, an endpoint which gets like a list of users, and then you can append this query parameter. And then every time you do this, I think the backend will only return the list of things that changed. So I think on the right, you can see I have an example of the response shape where you have the records, and then you have deleted IDs in case you want to soft delete some things, and then the created art and all that. So the only problem with this is that if the server time and the device time are out of sync, I think you can end up in a state where you're fetching the wrong data. So you have to be really careful about this type of syncing, and then have to implement it in a way that every time you do a call, you have the correct time, both on the device and both on the server. So that is one method of syncing. And the second one is called the change list version. So this is on the Now in Android app, which is like a good example I saw to highlight. So it happens in two phases. So the phase number one is where you discover what changed. So you have like a get request where the server replies with the IDs that changed. And then once you get this, you can do like a call to fetch all the things that have changed. So it's like a two-phase. So the number one thing, you just discover what has changed. And then secondly, after you have discovered what has changed, you have to now fetch the things that have changed. So that is on the right, you can see the code examples where you have like versions. So you change, you get, you do like a call to get all the things that have changed. And then after you've done that, it will return like a list of records that have changed. And then you do your second API call with the response from the discovery call. And after that, now you can do the insert in your DB. So the most favorable way to do these inserts is the upsert, where you update and insert. So what Room does, if you do like an upsert call, it will, for records that need to be updated, it will update them. And then for records that needs to be inserted, it will insert them. So let's look at how the worker will look like for all those two flavors of the sync. So we have like a work manager, you have to set your constraints, and then you have to restrict retries. So this is the same shape in both the Now in Android app and also the Field Agent app. So I was mentioning about the constraints that you can set in your work manager. So the number one is the network connected. So this is when you want to ensure that all the background jobs happen when you have like an active network connection. So that if you don't have an active network connection, there is no need of even trying to do that job. So secondly, you can set like an existing work policy. So this is an enum with a couple of different values. But for this case, I chose replace. So assuming you have like you have done a sync and then you retrigger the sync again, because most of the times if you start them like in a short period of time, I think the sync can be fetching the same things. So you have to set like a policy to handle such cases. So that's why you have like replace. So this will ensure that no single two syncs will happen at the same time. And then Work Manager also has this good method where you can get the progress for all your background jobs. So your UI will listen to the progress for your background jobs. And then the run attempt is inside the work manager again, because as I said, a work manager can work without any interference from someone. So you have to also ensure that you actually don't keep on retrying every single time, because when you do that, I think you'll be killing the battery of your app. And this is something that you don't want to do, because you'll find a lot of one-star reviews on Play Store where people are complaining that the app is using a lot of battery and all that. And then again, once you complete a sync, you have to like update your last sync date time, so that every time the second time you do a sync, you can always check this field and then tell the server to return the latest configuration or latest data per that sync time. So you can see the code example of configuring that manager. You can set your constraints and then prefer the one-time request. And then also when you're trying to create like your work manager instance, you set it, give it our name, and then give it a policy, and then give it your request. So, and this is a real life scenario that I've ever faced when you're trying to do the background things. So if you're trying to insert a lot of records, for example, like 15,000 rows, you can turn like a 5-minute sync into like a 2-hour thing. So let's see how that happens. So you have like a sync which downloads like a lot of records, that is like 15,000. So you insert each row at a time in a loop because you have like a list of items and then you have to insert each of them. And then if you're configuring the flow, so what happens is every time you insert a record and your UI is observing, it will emit like that list to the UI. And then every time you update like a record, it will emit to the UI. So you can imagine if you're trying to do that for 15,000 items, that will be very slow. And you'll find that the sync is taking even more than 2 hours. And you can actually face what we call like database deadlocks because you're doing something in a continuous loop and also trying to emit it to the UI. And then the fix for that is also trying to, because Room out of the box offers some of the fixes for that, is you can wrap your insert in using the transaction annotation, which tells Room that this is one operation that you have to do. And once it completes, it will notify all the observers. Secondly, is also try to handle the conflicts, especially per field level. So the example here is you can use the replace. So this will avoid that loop where read and then update and all that. Also, the other good thing is, and you'll find this in most of the application, you can hide the list while you are trying to fetch all these items, especially when the user is fetching items for the very first time. You can have like a very nice loading animation. And then once that finishes, or once Room is ready with all the data, you can now be able to take them to show the list. And especially when you're working with flows, we have a bunch of utility functions that helps you to reduce the number of times you update the UI. So you have the conflict and then the sample, which really helps you to reduce the number of times or set like a minimum time where you get the updates. And then one important thing that is because we're also doing a lot of background jobs, ensure that all the things is off the main thread. And then the good thing is in coroutines, you have like dispatchers.io where you can actually do things off the main thread. And then how do we keep the UI in sync with our background work? So we have like a single source of truth where you have one path for updates and one path for writes. So every background write goes to your Room database. So you have a worker and we have a repository. Remember I said like repository is normally gives you like the source of truth. So everything that needs to talk to, let's say, your database or a remote API needs to call the repository. And then the repository will call Room. So you never bypass this because it can end up in situations where, again, your UI is not in sync with the background work. And then all your data access objects return a flow, which I said is a stream from Kotlin. And then when you need to do renders, you only have the persisted changes. And then again, use the collect state with lifecycle, which is a really lifesaver, especially when you're working with Jetpack Compose, because every time a user navigates away from that screen, it will stop observing all your active flows, and then it will also clean up all the resources for you out of the box. And then you can also have the hot flows where you have like one upstream collector and then a lot of downstream UI observers. So you only have like one upstream, which collects all the flows from your Rim database. And then for your downstream observers, you can have a lot of them. And then Surface sync set separately. So for this one, I think if you've ever used the Google Photos app, you can see next to your profile, there is normally a very good animation where it shows you the state of backing up. So that is like a recommended example where even if you're doing things on the background, at least show the user like, yeah, we are doing something on the background and this is the progress. And also when you have like errors, you also try to configure them in a very nice way. And then when you're also trying to make your state, make it like a seed class. And this helps in trying to make sure that you handle all the cases and all the cases have their UI. So for example, I have like a background sync status. You can have like a queued, started, progress, success, cancelled, and failed. So this helps you in also trying to surface every state back to the user so that you can't have silent failures or silent kind of where you have like a UI with blank things because you didn't handle that case. So that's why if you have a state, try to model it with like a sealed interface or a sealed class, whichever you prefer, so that whenever on your UI, you can observe all the cases. And in each case, for example, if you have like a different UI to show when you're queuing, progressing, or when the job is started, you can handle that separately. And then the part two of the architecture is maybe dealing with how you write offline. So let's explore that. So the number one rule is always try to write in Room first and then queue the upload. So by queuing, this is where the work managers come in. So you, for example, someone is filling a form, so you can save that offline. And then once the form is saved offline, you queue the upload and then surface the state in the UI. So it's as simple as that. You write locally and then enqueue that. And on success, you ensure that you have like a field that tracks when you updated that record. I think when you're modeling like all your entity classes inside Room, especially for offline fast, I think you'll have a lot of timestamp fields. So updated art, created art, deleted art, so that every time you need to handle conflicts and all that, you can always check on these fields and then do like a reconciliation properly. And one thing about writing offline is you can never have a state where you saying that you cannot save offline, or in case someone doesn't have internet, you just tell them like, hey, we cannot save your data. So the writes have to always happen. So you have to treat your writes like you have to do them in a very nice way so that users cannot be in a state where they see such an error. And then, so how do we handle, once you do the writes, how do we handle the uploads? So this is an example job that shows you a bunch of best practices of how to configure like the jobs. So number one, I think, is now grouping all your jobs so that all the jobs can be groups if they're doing like related things. For example, you have different types of upload, you can group them by a group. And then you have like the param which just specify that require network. So this is very helpful in that, as I mentioned, when you don't have a network connection, you prevent the user from actually trying to do an upload. And then we have the last thing on the params object is the .persist call. So this normally helps all your jobs to persist even across process dead or across all the app restarts and all that. So once you configure that, you'll ensure that all your uploads are very durable. And every time, even if your app reboots or even if the user reboots like the whole device, the Work Manager will handle this for you. And then the other best practice to do is also have a backup or have a period where if this has been happening for the last, let's say, 8 hours, you stop trying because again, you're also trying to save the battery for the user. So you can't keep on retrying these things because network calls are very expensive. And remember, again, we're working on devices that are not on the best of the conditions. So you have to ensure that if you've been trying to do like a job for a very long time, so just try to back it off and then you can save that state elsewhere and then try to retry the job later. So there is also a bit of reconciling and how do you handle that? So we have three approaches. So you can have like a last write wins. So this is as simple where the last write, so you can use the server's timestamp and then it will always be the source of truth. So the only thing is you can lose data in case you have something that was updated offline and was not synced. The second approach is where you have like soft deletes. So you have like a deleted art column inside your database, and then you do like a soft delete, and then you can also, in case you have conflicts and in case you don't have in case the thing has not happened, you can always come back and then try to resolve that conflict. So I think typically is you can have the deleted art is only updated on a successful sync. So that's how you can be able to know like, has this been updated? Has this been uploaded or that? And then we have also the third strategy, which is like the strongest, where you track each field and then compare the server changes, compare the local changes, and then ensure that whatever that is locally and isn't updated on the server is not lost. So whatever you pick, I think the rule of thumb is always try to document it, because you'll find most of these bugs or most of these things, if you never communicate with the team that this is the approach we're using on reconciling between local and remote, uh, you'll find a lot of bugs being filed, or you'll find a lot of people complaining about that. So documenting it is always good for the whole team to know. And because the reconciliation part is where most bugs can occur, because you actually don't want to lose any data, or you actually don't want to have a situation where you have updated copies on the database and people cannot actually get them. So you have to choose like the strategy that works best. And then there is also like a rule of thumb where you don't overwrite and unsync local edit. So assume this scenario, you have a user editing like a row offline at 9 a.m. and then at 9:05, you try to do like a sync, and then you get, because the server is not updated, you'll get like that old copy. If you overwrite everything on the local edit, on the local database, it means that the user work will be gone. And if you have seen, you'll have apps that require the users to do a lot of, maybe fill out a lot of forms, especially if you're doing like KYC or onboarding. You can have a scenario where a user is filling like 10 forms. So imagine if you lose that progress. I think this will be like a very frustrating user experience. And this is how you avoid it. So you have to process the records one by one, and then compare, because I've mentioned you can have like an updated at timestamp. So you compare that with the synced at, and then once you compare, decide which one is the latest one, and then uh, if the local one is newer, ensure that you keep the overwrite, and if the server one is the latest one, you can overwrite the local one. So this helps you so that you don't lose the progress that you have locally, and also ensure that you also have like an updated set of records on the other fields. And so the part three is mostly just trying to share the lesson that I've learned as I've been working on the offline first architecture. And I mentioned this, so errors, treat them as first-class citizens, and then you also have to restrict them. So you can't have a situation where your retries are running forever, because you'll burn the battery, and also in the long run, people will avoid using your app because it consumes the battery, or every time they use your app, it always overheats and all that. And a good strategy is every error type, you can have like a category and distinguish them. So for example, you have network errors, which can probably be recoverable. And we have like errors that are not recoverable. For example, if a user faces like a 401, which is unauthorized in most cases, in that you don't have to maybe retry jobs after you face like a 401. So the key thing is ensure that you distinguish those error types, because taking the 401 example, if the user is unauthorized and they haven't gotten like a new maybe access token from the database, it means that your background job will keep on running. And if you don't cap the retries, or if you don't have a way of distinguishing these errors, the retries will be forever, which leads us to that case where the battery is also being affected. And also having like a exponential back off is good, where you have, even if it's a job that has been failing, like let's say for the last 8 hours, do a cap and then maybe do away with that job and maybe record it somewhere. And then the last, the other option is also do like have a hard fail, where you have, if you've tried a job maybe after X retries, just stop that job. So WorkManager, I think there's a code snippet there where you can see, you can get the run attempt counts from WorkManager. So it reports how many times have you run this job. And then, for example, the example uses 10, and then you can just fail that WorkManager because of too many retries. And the last thing about errors is also just track the sync duration. If Because if you notice that it's going up, it means that something is slowing things down. Um, and the thing about offline first architecture is you also have to have a bit of observability in mind, because most of these, because most of the times you are not in the field, you're just a developer working on this app, and the person using the app is probably in a last mile village somewhere. So you have to have a way where you get the observability and then track every, like the sync times, the errors, and if you notice that they are probably increasing, it's also time to check what is happening wrong. And so just to maybe recap, so you have like a cooldown. So for example, you can set like you have a sync every 3 minutes or every 3 hours, every 3 days, and all that. So that if we take 3 minutes as an example, if the sync, if you do like a sync now and then you have to wait 3 minutes, so it ensures in between these 3 minutes you don't do another sync. And then you can batch writes where you, the form example I was using, you have a bunch of forms and then uh, you don't have to upload all of them at once. So you can batch them so that it's not like one upload job. It's like a couple of them that can be successful. And then there is also trying to compress the job result, just trying to send like a small JSON result and not the whole entity, because at times you have a lot of fields that are only needed on the app and not maybe on the server side. And then there's also an issue of sending images separately. So we have the Amazon S3 SDK, which actually even works offline. You can be able to submit images, and then it gets you like a link, and then once you can save that link on your database, and then when you're sending all these results to the server, they have like the Amazon S3 link, and then they can be able to preview the images. So that ensures that as you're batching all the results on your offline, you don't have to send also images. And then you can also sync, you can also skip empty deltas. So if you do the last, if you check the scenes and then you find that you don't have any change, you actually don't even uh, need to hit room, because you have a field that tracks when you do the things, and when the sync is successful, you update it. So if you have nothing there, there is actually no need to even check room. And then you can also set constraints by network where you say unmetered. So if you have a lot of large payloads that you're uploading, this is really helpful, and WorkManager supports this out of the box. When you set the constraint to the network type unmetered, it will always upload when you have, like, let's say, unmetered network. And then, like a bonus, and this was mentioned, I think, in last office hours, you can also opt for server-driven UI. It's also like a very complex topic. We cannot exhaust all of it, but just to highlight why maybe server-driven UI matters in these kind of scenarios is you have users who don't often update the app. You actually find people who are on, let's say, your version 1.2 and your app is on version 1.8. And in case you have a lot of critical updates, it means that all the users are not going to get those updates because they rarely update the apps on Play Store. And then at times you'll find that Play Store reviews can take time. It can be hours, minutes, or days. So, and if you have a critical bug that is affecting like the user flow, you can't wait for all that time to ship the bug fixes. And then there is also like a issue of storage where your storage is all you're competing with other apps for storage. And I think users can have different variety of apps. So you have to have that in mind, that you don't have all the entire storage to your disposal. And we have UI changes are not mostly logic changes. So server-driven UI normally helps in that you can actually dispatch changes quickly over the server. And then every time the app makes a network call, they can get these updates very quickly. So a brief summary of how it works is you have a JSON spec that describes how the UI is. And then inside your app, you have built a renderer, which knows, for this JSON spec, how do I actually render the UI? And then lastly, you have the screen, which is rendered. So this is also very good for maybe large forms, KYC settings, and then if you have like a bunch of A/B settings that you have to do, you can also use them there. And then if you have a lot of heavy animations and custom interaction, I think server-driven UI can probably be a pain. So you have also to maybe put just weigh and then see if server-driven UI is actually something that you can consider, because it also needs work from the backend and also work from the front end. And then when you're working on offline fast, I think testing is also a critical thing, because this is a scenario that I was facing. You'll mostly test on your Wi-Fi, and I think your Wi-Fi is maybe pretty fast enough, so you never get the actual situations where users face. And a bunch of cool things to highlight is when you're using the Android emulator, you can always use airplane mode. You can always switch the networks maybe to Edge, to G, and then see how your apps fares on search. Again, you can also write roboelectric tests, and then always have like you can actually write like fake data for your APIs, so that you can actually test a scenario where you have maybe large records, and then insert them into your database and then see how it fares when you actually try to test on 2G, 3G, and all that. And then again, WorkManager supports you writing tests. So you can use the test worker builder to actually write tests for your WorkManager, and always ensure that every time you make a change to your WorkManagers, they and the tests are passing. And then you can always have like a snapshot of room contents before and after sync to like compare. Yeah, so testing is very critical, and it ensures that once you set like this test in like you mimic them in like a very production like environment, you can be able to catch most of these bugs early enough. And then to summarize, or maybe to highlight like 4 things maybe to take away from this session, is when you're trying to build your next offline fast feature, number one is that local database is the single source of truth. Number two, you have WorkManager, which helps you to sync things in the background. And then number three, you are not supposed to be blocking users. So the UI should maybe show progress, animations, and all that. And then on the reconciliation, do it on purpose. So pick a strategy and then document that strategy, and never do like anything blindly. And other resources, I think we have the offline fast guide, and then the now in Android app that I was mentioning, WorkManager, which is helps you to do all the background jobs. And then we have the Room and flows and Kotlin flows on Android. So those are the resources. I think you can find them on the official links. And yeah, thank you so much, and happy to hear questions.
Awesome. Thank you so much, Harun, for that in-depth um, talk on offline first architecture. Um, for once again, real quick before we get into the Q&A, I want to apologize for the folks on LinkedIn. We had that technical issue where we couldn't stream today, but we'll make sure to button up that next time. And now we get into the Q&A session. Real quick here. Let's see. We'll start queuing up your questions and answer it. Given we started a little bit late, we'll go over approximately 10 minutes so we can have at least some chance to answer some of these questions. And if you can get to all of them, we will try and answer some of them next time in 2 weeks. Thank you.
Yes, so these are very nice questions.
For users in SSA with less than 8 gigabytes of usable storage, how do you manage room database growth over time? What's the best strategy for evicting old cache data? Harun?
Yeah, thank you. So mostly, as I was saying, you will find that on your database, you have a lot of timestamp records, and every record has to have like maybe updated that, deleted that, or synced that. So eventually, maybe over a couple of time, you can always come back and then query that, and then ensure maybe together with your backend team, decide if something is maybe older than 3 months, 6 months, maybe do away with it. And I think those are things that you can configure either you're going with the change list version or if you're going with the query parameter where you get like the sync that. So, and then the other thing to highlight is on Room, I think you have the feature where you set records to cascade on delete. So for example, if you have a user's table and then you're trying to delete something, so if you delete a single user and then ensure that everything that is associated to that user is also deleted. So that also helps you keep like all the records also deleted in terms of when you're deleting records.
Thank you, Arun. Let's move to the next question. On devices with only 1 to 2 gigabyte of RAM, does keeping these database observers active cause memory or battery overhead compared to simple one-time reads? Really good question as well. Do you want to take that, Harun?
Yeah, I think I can take that. So I think this is also like the case I was mentioning, where if you keep on observing the UI for every time you do like an update or a read or a write, I think you'll find areas where it takes a lot of memory and then you get like a lot of deadlocks. So you have to have like a smart strategy on how you're keeping like your UI observers. And the first go-to resource is the collector state with lifecycle, which ensures every time you go away from that screen, any observation will not stay in the background even if you're not needing like observing the data. So yeah, that normally helps. And then once also trying to ensure the strategy that you use to do like inserts and then dispatch to updates with the UI, I think is very critical, especially for the first time sync. Because if you're inserting like 50, the example I gave is you have a large number of records, so you have to be very keen on how you are doing the insert and then dispatching the updates to the UI.
Yeah, to add quickly here, I think the other piece here is like rooms observers are very highly optimized, right? So, what really kills memory is the downstream UI updates. Um, and so making sure that you always map or filter data on dispatchers in a view model before it hits the UI. So like dispatcher does default, or using dot conflate or sample and so on. So it's really where you have to pay attention where you're doing the operations downstreams for the UI. Next question. If the UI spec updates on the back end, but um, the user is offline, how do you handle versioning to ensure the data they submit locally still matches the backend's expected format when it finally syncs?
Yeah,
I
interesting
believe,
question.
yeah. Go ahead. Sorry.
Yeah. So in the JSON spec that I mentioned, one thing that is if you're doing server-driven UI, you have to have like a version. So let's say you have version 1, and then every time you do like a change on the JSON spec from the backend, you have to bump the version up. So let's say version 2. And locally, I think it has to also track the version so that even if a user maybe saved the data with version 1, it will also be valid. And then once they update like once they fetch like new data, and then Room will update the new version, and then they can also be able to update. Uh, they can also be able to use the version 2. I think this is mostly even like a backwards compatible thing where on the backend you also don't ensure even older versions are working so that people can also use the different sets of version.
Yeah, I believe versioning is the right way to go here as well. Um, Next question. How do you prevent the OS from killing a sync worker before it finishes a critical update? Especially, this is very relevant for regions SSA and MENAT, right? Harun, I believe this is yours as well.
Yeah, sure. So I think when I was trying to give like an example upload job, I think there was the dot persist thing that you can use when you're trying to configure like patterns for a background job. So when you use that, I think it helps you or it helps persist that job from back process dev and also background when the OS kills all the jobs or all the things that are running in the background. So that one symbol configuration can actually help you.
Yeah. Also, leaning into work manager and deferral system here is can help instead of trying to uh, really optimize for foreground execution and stuff like that. Next, when a worker fails permanently, what is the best UX pattern to surface this to the user so they know their data didn't sync without making them think the app is broken?
I'll take
I
that.
believe, yeah, you can take that. I believe this is when I think this is in relation to like sync retries, um, like failing after a certain number of attempts.
Yeah, so I gave the example where you're using Google Photos. I think whenever you maybe tap on your profile, I think you'll normally see very nice updates when it's syncing. And then even if like a sync fails, I think they'll also try to give you like the status there. So it's always good to handle that. And Work Manager always supports you observing all the progress or the background jobs, and then you can actually dispatch those to the UI. So I think I showed the set foreground async, which you can use to actually observe UI updates and then handle them in a graceful way on your UI.
We can take a few more questions. Next one. How can we dynamically configure our work manager to only upload large payloads like batch analytics and high res photos when the user connects to an unmetered Wi Fi network?
I can take that as well. And I think on the slides, I also showed where you can use the configuration, network type and metered. So that always ensure whenever you're trying to do large uploads, it will always happen when the network type is unmetered. And also a good also way to surface that is on your app settings. Also try to ensure that people can also opt into those behaviors. So I think I love Google Photos in terms of doing all these large upload things. You can also see the settings where if you want to back up maybe your photos, videos, and all that, it asks you, do you want to back up over Wi-Fi, over data, and all that. And then do you also want to back up high quality or low quality?
Cool. Thank you. Um, Next question. If a sync runs and the backend returns no changes, what is the most efficient way to update the last sync time locally without accidentally triggering a UI recomposition? That is also for you, Arun.
Yeah, I think from previous instances I've done, you have like a shared preference where you observe that key. And I think every time you try to observe that, it's mostly off the UI like things so that every time, so for example, if you're trying to do a sync, your work manager queries from shared preference or data, maybe data store, and then that will not actually trigger any recomposition. The only thing that will trigger recomposition is when the sync is complete and then the UI updates are dispatched to the UI. So I think that is what I used to do.
I also think triggering a database update uh, just to update something like timestamp. I mean, I'm trying to say decoupling sort of domain data versus metadata can help here. Instead of if you just touch the room database to update a timestamp, it will likely trigger recomposition. So trying to decouple This is the domain data versus metadata can help as well. Next question. Should the Android client be doing the heavy lifting to figure out the merge, or should the client just send the local tips or enforce the backend to resolve the conflict? I believe this is as well. Yeah.
Yeah, so for this one, the strategy, as I showed, two ways of maybe doing the sync. And this is normally like a conversation and encourage you have to have with your backend team and also the mobile team so that you can actually discuss like the best way possible. And on the heavy lifting, try to ensure that only the critical fields are the ones that you're doing the heavy lifting so that you don't have like a lot of maybe processing. And one thing to add is I think normally makes all this operation very cheap in a way, so that if you have to do like one query to maybe check if the field is updated, it will be not that expensive. So the solution is have a strategy that works both on the back end and the front end, and then discuss with the team, weigh pros and cons, and then come back and then do the implementation.
I'm curious, Harun. I know at MyLID you guys have to handle a lot of images, uploads, and so on. How do you
Yeah.
handle this specifically at MyLID?
Yeah, so for images, specifically, what we do is as you're taking like maybe a selfie, for instance, I think we'll do all the checks to ensure that the selfie is according to our standards. And then when you're trying to save that selfie, we have one thing like the camera X allows you to maybe set like a compression where you can actually compress that image to the quality that you desire. I think there is normally like it's an integer and you can specify depending on what quality you want, and then send that over to the backend. I think, for example, with that, you can actually get even photos that are maybe kilobytes and all that, and they don't have to stay in the device when you're trying to upload.
Awesome. Thank you so much, everyone. Thank you, Harun, for joining. We are way over time, but given our late start due to the technical snafus, I thought it was important that we get to as much questions as possible. We do have a number of questions we weren't able to get to today, but we'll try to get to them during next session in 2 weeks. Before I let you all go, we'd love to get your um, feedback on how today's session went. Please take a moment to scan this QR code and leave us with your feedback. What worked, what didn't work, what would you like to see, any topics you would like us to cover in the next sessions, and so on. Thank you so much for joining us today, and we will see you in 2 weeks. Thanks, Harun.